I am Ahmad Malik, lecturer geography at Sopore. Today we are going to discuss chapter 3 geography, class 11, the interior of the earth. This module will help you to visualize and understand the composition and the structure of the earth's interior. In earlier class you may have studied about the landform processes. Let us recap again. There are two types of forces responsible for landform processes. One is endogenetic force and next is exogenetic force. Endogenetic forces are those which are operating from inside the earth, like earthquakes, volcanoes. Exogenetic forces which are operating on the surface of the earth, like weathering, erosion, deposition, moss wasting. In order to know the interior of the earth, the endogenetic forces are the true evidence of the structure of the earth. There are two types of the evidence: direct evidence and the indirect evidence. In direct evidence, we take rock samples, scientific drilling, which the scientists are able to go up to 12 kilometers, forest blast, which the scientists are able to do up to 100 kilometers at Kola in Arctic Ocean, and the volcanic eruption. In indirect evidence, we take earthquakes and seismic activities, gravitational force, and magnetic field. Scientists, scientific studies have revealed that there exists a layered structure of the Earth's interior. Let us know what are earthquakes. Shaking of Earth is called as earthquake. It is caused due to the release of energy waves that travel in all directions. See in the diagram. The point at which the energy is released inside the earth is called as focus. The point where it touches the surface of the earth is called epicenter. The scientific study of the earthquakes is called as seismology. The instrument used to record the tremors is called as seismograph. The scale which records the intensity and the magnitude is called as the Richter scale. Dear students, all the earthquakes that take place in the lithosphere is due to the following reasons. Number one, movement of the tectonic plates. Second, volcanic eruptions. Third, movement of the convectional currents. Due to the earthquakes, two types of energy waves are released, which travel in all directions. These waves are called as seismic waves. See in the diagram. Seismic waves are of two types. What are seismic waves? Seismic waves from the earthquakes are used to analyze the composition and the internal structure of the earth. The seismic waves are of two types: body waves and the surface waves. Let us take first the body waves. Body waves travel through the earth's inner layers. They are used by the scientists to study the earth's interior. Surface waves. These waves cannot travel through any liquid medium. Seismologists conclude that outer core is liquid. Let us take first the body waves. Body waves are of two types: primary waves, referred as P waves; secondary waves, referred as S waves. P waves. These waves vibrate parallel to the direction of the wave. These waves make compression and expansion movement. They travel in all medium, that is crust, mantle and core. In crust, they travel at a speed of 6 kilometers per second, while as in the mantle they travel at a speed of 8 kilometers per second. These waves are recorded in all places on the Earth except between 103 degree to 142 degree from the epicenter. This zone is called as P shadow zone. S waves. These waves vibrate at perpendicular to the direction of the waves. These waves make crests and troughs. These waves travel only in the solids, that is in crust. These waves are slow as compared to the P waves and travel at a speed of 4 kilometers per second. Let us go to the diagram. This diagram shows the amplitude of all these waves, P waves, S waves, and the surface waves. Next slide. In this diagram, the yellow arrow shows the P waves, while as the black arrow shows the S waves. Yellow arrows indicating the propagation of the wave in all parts of the earth except between 103 to 140. This is known as P shadow zone. Black arrows show the S waves. They get deflected as they reach in the middle. Next. This diagram shows the propagation of the P and S waves. In P waves, this diagram shows the compression and the expansion of the wave, while as in S wave, they show the crests and the troughs. Next. Is called Next type of the waves is called as surface waves. Surface waves travel through the surface of the earth. These waves arise only after the P and S waves. These surface waves are further divided into two types. One is relay wave, referred as R waves, love wave, referred as L waves. R waves. These waves named after the scientist William Stott, Lord Rayleigh, who mathematically predicts the existence of this kind of the wave in 1885. Love waves. These waves named after the A.H. Love, a British mathematician who worked out the mathematical model for this kind of the wave in 1911. R waves. These waves travel horizontally, making ripples just like the water waves. These waves eliminate through the distance. These waves travel whole circumference of the earth. These waves are more violent and destructive as the amplitude of the wave is very high. L waves. These waves travel horizontally at the perpendicular to the direction of the wave. These waves are faster than the R waves. See in the next diagram. This is the propagation of the surface waves, R waves and the L waves. Dear student, these are the main characteristics of the seismic waves. We show the evidence of the layered structure of the Earth's interior as we move from surface to the Earth towards the center of the Earth. See in the diagram. There are the three concentric circles indicating the three layers of the Earth. The thinnest layer of the Earth is called as crust, which extends up to the 40 kilometers. Beneath the crust, there is next layer mantle, and the innermost circle is called as the core. In the next diagram, we will find the cross section of the interior of the Earth. Each layer is subdivided. Each layer is subdivided by the two. Let us discuss one by one. The crust. This is the thinnest and the outermost layer of the Earth that extends up to 40 kilometers. Crust is further divided into the two, the continental layer and the oceanic layer. The continental layer, the thickness of this layer extends from 30 to 40 kilometers, and the density of the rocks in this layer are found 2.7 grams per cubic centimeter, and the composition of the rocks in this layer are contains silica, oxygen, aluminum, calcium, sodium, and potassium. This layer, the rocks in this layer are less denser, like granite. In the next oceanic layer, the thickness of this layer varies from 7 to 10 kilometers. The density of the rocks in this layer are 2.9 grams per cubic centimeter. This layer is found under the oceanic floor, and the rocks in this layer are denser, like basalt. The next diagram shows the mantle part of the Earth. This layer is beneath the crust, and its thickness is 40 to 2,900 kilometers. It contains 80% of the Earth's volume and 68% of Earth's mass. The mantle is further divided into two subgroups, that is upper mantle and the lower mantle. In the upper mantle, the rocks are in solid form, and the thickness of this layer is about 100 kilometers. There exists the tectonic plates, 7 tectonic plates and 12 minor plates which rest on it. In lower mantle, the rocks are in the molten form, and the thickness of this layer is about 800 kilometers. This layer is also called as mesosphere. Let us go to the another layer of the Earth that is called as the core. The core, this layer is the innermost layer of the Earth. The temperature at the core is about 5000 degrees Celsius. The core is further divided into two subgroups, the outer core and the inner core. In the outer core, the rocks are in the semi-solid form, and the thickness of this layer is about 2250 kilometers, and the density of the rocks in this layer are 10.79 grams per cubic centimeter, and the composition of the rocks contains the minerals like nickel and iron, while as in inner core, the rocks are in the solid form due to the high temperature and the pressure. Thickness of this layer is 1298 kilometers, and the density of the rocks in this layer are 15 grams per cubic centimeter, and the composition of the rocks containing the minerals nickel and iron. Next, I hope this module will help you to understand the structure of the Earth's interior. Please go through the assignments. Number 1. Draw a neat diagram showing the interior of the Earth. Second, draw a neat diagram showing the seismic waves of the Earth. Thank you.